Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access the event later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for two $50 Amazon gift cards, so please stick around. Hopefully you'll be one of our 2 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is downsampling time series data at scale. Our speaker today is Chris Clark, who is a DevOps engineer at Wayfair. Hey, Chris, how are you? Thanks for joining me today.
Doing well, thank you, Charlene.
Awesome, awesome. All right, well, I know you've got a great webinar on tap, great presentation, so I'm gonna put myself on mute and let you get right to your presentation.
Perfect. I'm just going to go ahead and jump right in. First, letting you all know a little bit about what Wayfair is and what sort of work we do, a little bit of history on myself, and then this presentation is going to sort of take you through an approach we took to designing an aggregation framework for some of our time series data, and sort of take you through the thought processes we had as an engineering team here at Wayfair, and why we settled on the approach we did, and some of the future changes we're planning on. So for those of you who don't know, Wayfair is an e-commerce company where we focus on home goods and furniture. We first showed up on the Fortune 500 list last year, and we were added again this year. Our net revenue back in 2018 was around $7 billion, just to give you sort of a scope of the scale that we're working at. And in terms of what my team, the metrics team, actually does within the Wayfair organization, we're maintaining InfluxDB as our time series database of choice, the pipelines that move measurements around Wayfair's infrastructure, and then we're also maintaining some Grafana clusters for other engineering teams and stakeholders to leverage in terms of monitoring their services and looking at performance over time. Also, just in terms of our scale, we currently have 5 logical InfluxDB clusters with 2 instances running in 2 data centers for redundancy and failover. Myself personally, I joined the metrics team at Wayfair back in November of 2018. And prior to joining Wayfair, I'd worked in the entertainment sector as a theatrical automation engineer, doing some work in television and film and things like that. For those of you who aren't familiar with time series data as a concept, it's pretty much what the name says it is. So it's going to be data that's going to have timestamp controlling the x-axis. It's generated in usually regular or irregular time periods, depending on if you are sort of monitoring something or if you want your metric to be emitted based on an event happening. There can be huge volumes, and in most cases, the data is meant to be real-time and time-sensitive. So the standard sort of real-world examples we give around what is time series data, the obvious example from the world around you is weather over time. For example, temperature or rainfall. So if you were to take temperature and record, how hot it is outside on a regular cadence, and you have that timestamp as a part of your data, that is now time series data. In the world in which the Wayfair metrics teams works, most of the data we're looking at is system sort of statistics in terms of CPU, RAM utilization, calls to a particular API, or execution times for a particular process within a system or a service. Just to give a little bit of context around what sort of led to this aggregation project that I'm going to be speaking to, before you is what time series at Wayfair used to look like before we adopted InfluxData's tick stack. So previously we were using statsd for our pipeline, a custom version that Wayfair authored statsdcc and then open source. We were using Carbon and Graphite for storage and data exploration of those metrics. And what prompted us to start looking at other ways to store this data and move it around is that we were starting to have issues around scaling our pipeline. As you can see, this is a very complicated mesh between our multiple data centers in terms of making sure we're replicating the data and moving it around. And then the other problem we started running into is that within the Carbon world, for every series within your time series data, you end up with a discrete footprint in terms of storage. So as we were starting to onboard more teams and having more metrics within the pipeline, our storage growth was unsustainable and just growing in an exponential fashion. If you'd like to know more about why Wayfarer selected the TIC stack and a little bit more about this migration away from statsd/carbon graphite, you can check out our tech blog, tech.wayfarer.com. And if you look for a post from Jim Hagan back in April of 2018, he really speaks to why the team moved in the direction that it did at that time. So we moved away from statsd and towards InfluxData's TIC stack, and we ended up with a pipeline that's a lot more simplified. The new pipeline design decoupled our receiver layers from the storage clusters themselves by putting some Kafka in the middle. It also made the overall pipeline a lot more scalable in that we could just add the first half of the pipeline into any new data centers we spun up. And it allowed for us to easily have duplication between our primary and our DR clusters by just adjusting where we were mirroring that Kafka data to. We currently have 3 of these pipelines handling different logical clusters that we've built out, with the data going into those 5 different logical InfluxDB clusters, with each having between 6 and 12 data nodes in there. In terms of what this gave us around our previous problems, series was no longer the driving factor in terms of storage. It was just the sheer number of individual points of metrics coming into the pipeline. By getting rid of statsd, we were then able to allow our end user customers, the internal engineers at Wayfarer, to access more of their raw data. And it, like I said before, was very easy for us to add additional data centers as we spun up new infrastructure. And we started off holding on to 14 days worth of data within these InfluxDB clusters. And then we increased that up to 30 days before we started running into some storage and performance problems around that. So what we learned after we shifted away from that statsd carbon graphite stack is that the raw data is great in terms of giving you a very fine granular view of what's happening within your services and infrastructure. But something we started noticing early on is that querying longer time windows became a real problem with some of the high volume measurements we had in our stack. So that was where having raw data was really starting to be an issue for us. We hadn't realized just how much statsd was doing to help the previous system in terms of doing all that aggregation and downsampling at the very front end of the pipeline. So there were a lot of measurements that were coming in that had some very big swings in volume that we just weren't aware of because we'd never seen the raw data before. One of the primary problems we'd had on the old platform had been mostly on the write side as opposed to on the query side. So as we were standing up the new TIC stack, we were heavily focused on the write performance of the cluster. And something that we didn't realize until a little bit later on, once we started moving users over to the new platform, was that even if we can keep up with the writes, we're not going to necessarily be able to handle writes and the queries at the same time. Just some things we ended up being able to adjust to handle the load, but something that we weren't really necessarily expecting to deal with early on. And then as stakeholders started getting used to the new platform, back in our carbon graphite days, we'd had sort of some continuous downsampling going on as data aged out. So we had less granular data that we were holding on for much longer periods of time. So stakeholders started to ask for longer lookbacks, more retention. But as we got to that 30-day mark with our raw data, we found that much beyond that, we ended up having some real constraints around storage footprint, as well as just overall cluster performance as we were holding on to more data and people were able to query back further in time. So just as an illustration of some of the volume swings we see within measurements within our pipeline, this is looking just sort of at the counts per minute on some of the measurements that go through widest swing. So we see that it ranges from 50K when things are quiet all the way up to about 400K. So volume swings of 8x across multiple measurements, and you start to get an idea of just the volume problem we were starting to face. So we realized we need to start coming up with some solutions for this. And so being the engineers that we are, we first focused on some short-term solutions. And the first thing that we did was leverage a tool that we wrote internally at Wayfarer called Trimmer. This is a tool that allowed the metrics and logging teams to move data around our pipeline, replacing Logstash within the Elk stack that we had. And in terms of the metrics team, it stood in place for Telegraf within the tick stack. It allowed us to use rate limiting to protect our clusters from those big swings in volume we saw by putting fixed rate limits per measurement into our pipeline. It allowed engineers to still have a really good view of their data over time while protecting overall cluster health. What we also did in terms of short-term fixes was to create some additional retention policies within our InfluxDB clusters and some scripts to move data between them. And this was a great solution for some really low volume measurements that we had within our big high volume environment. But for us, it was something that didn't scale very well because we're talking about a very manual process. We're updating scripts, using Puppet to add in new measurement names or to update the script that's moving data around between the clusters. Depending on sort of the scale you're working at and sort of the type of data you have within your time series database, something like this might work as a long-term solution. But for us, we were looking for something that was less manual, less ad hoc, and would be able to sort of handle all of the measurements within our cluster, not necessarily just those we wanted to whitelist into an aggregation solution. And then another thing we did was to create some standalone open source InfluxDB instances for certain teams that had very specific retention use cases and some specific policies that were unique to their data sets. So this allowed us to hold on to that data for much longer periods of time. We lost the high availability benefits of being in a clustered environment, but for these teams, this was the best solution until we had a more modular and sort of aggregation solution that met more use cases. And with all these solutions, the common thing we kept finding is that none of them scaled really well. It was very easy to define specific tasks and really aggregate very specific sets of data, but we didn't have a solution that would work for big groups of data or eventually all of the data within our InfluxDB clusters. So we knew we'd have to have some sort of aggregation solution that worked more broadly across the goal. So the initial project goals were really focused on making those high volume measurements that went through those big swings more queryable over long periods of time. And so most of these are performance metrics coming from services sort of at the very edge of our stack. So where our end users of the website actually really interact with the site. We also wanted to reduce our storage footprint / have more predictable storage in terms of overall long-term capacity planning for capital expenditures. And we wanted to get rid of those specific retention policies that we created for those handful of teams, just because we were getting to the point where we had 6 or 7 of them, and we knew that that was going to be something that would be incredibly hard to maintain for a long period of time. We wanted to keep this as invisible to our general front-end developers as possible. One solution would have been to have them downsample their data a lot more before sending it on to our infrastructure. But we wanted this to be as in the background as we could make it, just to remove friction on their end. One of the goals was we found ourselves still running a handful of those really high volume metrics through our old StatsD carbon graphite stack. So we needed a solution that worked for those measurements to be able to decommission them fully. And then we knew that we would want to have multiple roll-up windows based on what we'd seen with how carbon and graphite were cleaning up the metrics we had stored in those platforms. So we knew that we'd want a 1 hour roll-up window, and that we'd want a 10-second roll-up window, and that we'd want to do some sort of aggregate at around either the 1 minute or the 5 minute sort of viewpoint. So with that in mind, we had an idea of what we wanted our solution to do in terms of deliverables. And then the next thing we started thinking about was what sort of aggregates do we want to preserve out of this data? And this was a really simple solution for us. We just looked at what we were getting out of StatsD from the previous pipeline, and we just decided we were going to start off with that. So the initial thing, we were just looking at the aggregates you see on your screen and ways to produce those within a pipeline alongside our existing infrastructure. So in the POC, we tried a couple of different solutions towards creating this aggregation system. The first thing we tried to do was aggregation within the pipeline itself. So at that time, we had some extra Telegraf instances running alongside the overall pipeline that I showed you a few slides ago. And what we ran into here is that we ended up with extremely inaccurate aggregations because the current pipeline didn't make sure that all of the points in a particular series was in a single node to be aggregated. So we just ended up with basically nonsense data at this stage. We knew that there were ways that we could solve this within the pipeline itself. We'd actually done something similar in creating StatsDCC by having a hashing layer that made sure all the points from a particular series ended up in the right place. But in terms of the time we had and the effort we could spend on this project, we knew the solution, but the lift was just too big for that to be something worth pursuing for us. So we passed on doing pipeline aggregation initially. Another solution that's available within InfluxDB is the concept of continuous queries. And so that's where Influx can be running aggregate queries on a regular cadence on a job that's set to run, with a predefined frequency. For us, this was something that was going to be hard to maintain just because with the number of measurements we have in our clusters and the fact that those measurements are created by a lot of developers who are spinning them up on the fly as they need to, as they create new services. It was going to be very hard to keep the continuous queries up to date with all of the measurements within our databases. And within Influx, you'd have to have the measurement specified within the continuous query. So we knew it would be hard to maintain. For us, it was also going to be expensive because continuous queries run on the data nodes within that InfluxDB cluster. So we did some initial trials with continuous queries and saw that there was a significant impact in terms of CPU utilization on those data nodes, and that we would likely have to expand the clusters to do it. And with our current licensing from Influx, that would mean we'd have to have more of those data nodes and larger clusters, which was a cost we were looking to avoid at the time. And just like our previous solutions, it didn't scale well in terms of handling new measurements and adding things to the aggregation solution. The next thing we tried in our POC was Kapacitor, the K in Influx's tick stack. Kapacitor worked out of the box for us, which was great. Early on, we ruled out the subscription model for sharing data with Kapacitor, which is where your influx data nodes will pass on every point they receive to Kapacitor. We tried that out early on in the POC, and as you start to add more Kapacitor nodes, you're just sending a lot more data in and out of those data nodes and further stealing resources away from those license-constrained VMs. So we ruled out the subscription model. And then something that we really did like about Kapacitor is that the way you're creating jobs within the system, you can template out the script that they're going to run and then create new tasks that fill in some variables within that script, which would allow us to scale this quite quickly and quite well for our application. And then early on, we started to notice that memory was likely going to be the biggest pain point for us in terms of moving to a capacitor-based aggregation system. As we noticed, the longer you were holding on to the raw data, the more your memory utilization would grow quickly, depending on the number of series within a particular measurement. So coming out of the POC, as we were getting ready to move to production, we knew that there were some questions we were going to have to work out. So the first one for us was whether to use the open source version of Kapacitor or to use the enterprise version. And for us, this was really simple. We went with the open source because there were no benefits for us in the enterprise. We're not using alerts within the Kapacitor engine as part of our alerting infrastructure at Wayfair. And there was no cluster-wide management of tasks, so we knew that was going to be something we were going to have to solve ourselves. So we just went with a bunch of standalone open source nodes. The next thing for us to figure out was if we weren't going to be using subscriptions to get the data from Influx to Kapacitor, how do we get the data from Kafka where we have it all aggregated into Kapacitor? So that we didn't have to solve the hashing solution, we know that we need a solution that made it so that all of our data points went to all of the Kapacitor nodes that were running these aggregation scripts. The existing version of Trimmer that we were using within our pipeline didn't work since it was very simple. It had a single off-ramp, no sort of multicasting solution. And we couldn't really use Telegraf at the front end of our pipeline since it doesn't have that rate limiting that we were using Trimmer for in front of our raw data clusters. And we wanted to try and keep the data as consistent between those platforms as possible. Luckily, a solution presented itself to us in that the internal team at Wayfarer who'd been working on Trimmer had a newer version that was available that could handle multiple off-ramps. So we decided to use that as the front end of the aggregation pipelines. And then the next thing we had to solve was how are we going to deliver the templates and the tasks? The initial POC, we were just using files to deliver both the templates and the tasks, being shared out to the nodes using Puppet to orchestrate that. But that was something that we knew we didn't want to use for our production system because to read in the new tasks, you'd have to do a service restart, which we knew would add downtime in a way we didn't want to. And so we wanted to keep deploying the templates via Puppet since they were static, but we wanted to come up with a solution that would deploy the tasks via the Kapacitor API, since we'd be changing those based on the measurements within our pipeline, which we knew would change on a daily, weekly, et cetera basis. So at a very early level, this is sort of the basic design we were figuring we were going to need, where we would have our original pipeline still running in the background, where Trimmer is reading out of Kafka and writing to our raw data retention policies. And then our original design called for us to have another layer of Trimmer, which would be reading from Kafka right into Kapacitor, and then Kapacitor would be writing that downsampled data back to a different retention policy or database within the same InfluxDB cluster. Now, as we were moving into production, there were some questions we knew from the POC that we also would need to answer, trying to figure out what those final roll-up windows would be, and sort of negotiating in terms of that minute interval, whether 1 minute was too granular, or if 5 minutes wasn't granular enough in terms of balancing our overhead and storage capacity with the granularity that the developers would like to hold on to. Also coming out of the POC, we knew that we couldn't hold on to raw data for much more than a few minutes without running into some serious issues around memory utilization. And then with that in mind, we knew we were going to need to build VMs that were going to be extremely memory heavy. So at the same time as we were building this project, we were in the process of moving some of our infrastructure into GCP. So we were starting to look at what sort of VMs would fit that footprint in terms of having enough CPU for when the aggregates are actually computed, but also having a lot of memory available to hold on to the data as it's being waited to be aggregated. And then we were trying to figure out where to store the data, whether to create new InfluxDB clusters for the aggregate data or to keep it in the existing ones that we had. Our concerns here were once again around sort of the query load coming into those data nodes, as well as the write performance in terms of having two different pipelines going into those clusters. And then we knew that we would have to somehow generate the tasks for the capacitor nodes and come up with a way to distribute them, since we were distributing the templates via Public, but we were intending to add the tasks via the API. So in terms of how we generate the tasks, since that was going to be something we had to solve anyways, we started solving that problem first. We created a system that would query the influx clusters, gather metadata around measurement, volume, and series, and then start creating the task variables that were going to be used by the tick script templates running on the capacitor VMs, and start syncing those tasks out to the various nodes doing the different rollups. So this is just sort of a very simple diagram of how that workflow was working. And so basically, on a regular schedule, we'd have the metadata gather process happen, which would update our local cache, and then generate tasks would be running using some guardrails, looking at the local data on those measurements and creating those tasks before another job picked it up and synced it out to the various nodes doing the different rollups. So as we actually got things running in production, we discovered a couple more lessons. So our tool trimmer had initially been built to protect the influx clusters behind it from spiky and bursty data. And in creating the aggregation pipeline, we had created very spiky data. So our 10-second aggregates were only being emitted every 10 seconds. Our minute-based aggregates, every minute, so forth and so on. So we knew that we'd have to replace trimmer except for the initial layer within the pipeline. So we went back to Telegraf just because that handled the bursty data fine and would keep retrying to deliver the data if it ever had any sort of failures in terms of an API being overwhelmed temporarily. Memory pressure did continue to be the biggest pressure coming out of the POC and going into production. So 1 hour rollups were absolutely out the window in terms of using raw data. So we knew that those rollups would have to be aggregates based on the earlier 10-second aggregates. And so our question was for the minute-based aggregates, whether we'd use raw data, which we could barely sort of at that window, or if we'd go with the 10 seconds. And for consistency and being able to compare sort of what we have at the 1 hour and the 1 minute, we went with both using rollups of the 10-second aggregates so that they would be able to compare against each other sort of as a way to make sure that neither pipeline was having issues. Something that we didn't realize until we were well into production is that Kapacitor doesn't batch messages when it's writing out to InfluxDB. And so depending on the volume that you're working with in your aggregation, that can have a huge impact on the influx cluster. So in our case, since we were creating lots of points for lots of series in many measurements, every time we'd hit a burst of those aggregates being ready to roll out of Kapacitor, that was a lot of direct writes to the API without batching, and something that just would not be sustainable for us. And something else we discovered was that Kapacitor can't write directly to Kafka. Once we'd realized that we want our 1 minute and 1 hour rollups to be working off of the 10-second aggregate data, we figured we'd write that back to Kafka, read it out, and write it into the aggregate data store, but also have it available in those Kafka topics for our 1 minute and 1 hour aggregate pipelines to be able to reconsume. And so we realized we'd need a layer to present an InfluxDB write endpoint that Kapacitor could write to, but then would also be able to write the data to Kafka. So from that very simple design, what our final production design actually ended up looking like was this. So at the top, we still have our original older version of Trimmer writing to our raw data clusters. And then we have 3 essentially parallel pipelines doing the different aggregates. So we had that newer version of Trimmer at our first layer reading out of our raw data topics in Kafka and sending it to the Kapacitor nodes that were doing our 10-second aggregations. They would then write to a layer of Telegraf that would write that data back to Kafka. And then we would have another layer of Telegraf reading out of that Kafka topic and writing to retention policy for that initial rollup in a new separate aggregation cluster. So we ended up splitting out the aggregate data from the raw data. That data that first pipeline wrote back to Kafka, we would then use here later on to consume out for the 1 minute rollup pipeline, which is structurally the same, just going through the same steps. And then we would also use it for our 1 hour aggregates. And for the 1 minute and the 1 hour aggregates, we didn't strictly need to have this layer of Kafka present, but we weren't exactly sure how we would use the data, or if we'd want to have other consumers reading some of the aggregate data out and sending it to other locations. So we just figured having the buffering layer here, there weren't huge downsides other than a little bit more storage costs, but it gave us sort of more flexibility to redesign the pipeline later on down the road. So now that we had a pipeline running in production, it was time to see sort of how good the data was that we were producing. So this is a view of one of our high volume measurements, looking at some of the aggregates being produced in terms of the raw data, running an aggregate query against it versus querying similar data back out from the aggregate clusters. So as we can see, there's a little bit of highs and lows sort of getting slightly time shifted depending on when those data points hit the aggregate layer before making it into the storage clusters, but you're still seeing the story the data is telling you is still the same story. And so once we validated the data, the next thing for us to look at was what sort of improvements we were getting on the query side. And so using the dashboard that we looked at in the previous screen, reran similar queries to gather the data against our raw data clusters, and then against our 10-second rollup, doing different lookbacks in time to see how much more performant they were. And so we see even with just looking back at 1 hour, you can see an 80% improvement in the execution time of the query. But as you start looking back, beyond an hour and start looking at multiple days, you see significant improvements in terms of the query load time, especially when you're talking about sort of a real-time monitoring and dashboarding being our primary use cases for this data. For a dashboard, a minute 15 seconds is an eternity, and it's just unusable. But 230 milliseconds, is still pretty zippy and feels quick in terms of getting the data back out. So this was something that was a huge benefit for our end users whose data was now in this aggregation pipeline and going to these aggregate clusters. And then the future of aggregation at Wayfair. in the next 6 months, we're going to be moving to trimmer-based aggregation. Since we initially did this aggregation pipeline, the trimmer tool has matured in a huge way, and Wayfarer has actually open sourced that. If you're interested in taking a look at it as a tool for moving data around, you can visit the project at trimmer.rs. But part of what that team has added in is aggregate functions within the scripting language that they've created within it. So we are going to move to that platform for doing aggregation away from Kapacitor to increase the efficiency of it, because Trimmer is really well tuned towards being as efficient and performant as possible, and also to reduce the different number of components we have within the stack. Moving to Trimmer allows us to get rid of the current aggregation pipeline we have with all those various layers, reading and writing from different services, and move to essentially 2 pipelines where they're both reading from Kafka and then writing to different influx clusters. We're going to be expanding the whitelist of measurements as new teams add in data that we really need to downsample to make it queryable or is of high value to the company to hold on for longer periods of time. And as part of our moving towards trimmer-based aggregation, we're moving to a default sort of opt-in model for data meeting our volume and cardinality requirements. Some additional pipeline improvements we're adding a schema registry to do validation sort of at the front end of our pipelines to make sure the data we're getting is the data that developers expect to be sending us, to sort of remove some operational overhead for our teams in terms of responding to bad data that is poisoning sort of the shared pool of the infrastructure. And we're going to basically be leveraging that schema tool to generate the list of tasks and validate whether or not a measurement is a good candidate for being within the aggregation pipeline. And then on the query side, we're adding a proxy in front of our clusters, just because we've been looking at it more short circuits and guardrails throughout our stack, and helping to prevent bad queries from getting to the data nodes is a part of that. But by adding the query proxy, something else that it allows us to do is abstract out the multiple databases and retention policies where we're going to be storing the data, and allow for our internal stakeholders to just write very simple queries without thinking about sort of what sort of a time range they're looking at, how far back in time they're going, things of that nature, that sort of determine which retention policy or cluster is the best for them to send their query to, and just hiding that from them as much as we can, just to keep things as simple on them as we can. So yeah, I went through that a little bit faster than I'd been planning on, but that is sort of the history of this aggregation project at Wayfarer and sort of some places we're going to be taking it down the road.
Great, great. Well, plenty of time for questions since you got through that a little bit faster. That's never a bad thing. So if you have a question for Chris, please go ahead and use the GoToWebinar control panel and submit your questions. Let's go ahead and dive right on into what we have so far. First question, in retrospect, is there anything you wish you could have changed differently when you created your new pipeline?
There's quite a few things, and I think moving towards sort of the trimmer-based aggregation solution for us long-term is what we would have liked to have done ideally from the get-go, but that tool just hadn't matured to the point where that was a viable solution. It didn't have any of the aggregation functions at the time. Overall, we wanted it to be a lot more simplified than it ended up being, having those layers of trimmer and telegraph that are simply just there to sort of move data between other components that couldn't talk to each other easily out of the box was definitely less than ideal for us, but something that we're looking to solve sort of as we move ahead.
Excellent. Okay. Next question here. Is downsampling a native function in InfluxDB?
It absolutely is, and that's an approach we tried using those continuous queries. That's sort of the most efficient way to sort of do it within the InfluxDB world, and it definitely worked as a solution for us. It was just it didn't scale well enough in terms of making this as opt-in for the end users creating the data as possible, or excuse me, just automatic opt-in, and it also was going to drive up our costs in terms of licensing and really putting more pressure on those clusters, which wouldn't work for us long term. And with the continuous queries within Influx, it would create sort of a problem for us if we ever wanted to start splitting up the data and moving the aggregate into different clusters, since there wasn't a real good way with continuous queries to move the data to a different external cluster.
All right, great. Guys, if you have a question for Chris, go ahead and use your GoToWebinar control panel. I have plenty of time for questions. Here's our next question. How do you imagine Flux might displace the need for Kapacitor? Do you think it would influence your current architecture for aggregation, or would you simply use Flux functions where you used Kapacitor?
The honest answer is, I don't know. I mean, I think Flux could replace the sort of capacitor components we have within the current architecture. Just with where Flux is sort of in its rollout and us running the enterprise versions of Influx, we're just not quite there in terms of having it be at a point for us where we've had the chance to really learn Flux and kick the tires on it and get good with it. So it's going to be something that in the future we could potentially replace the capacitor parts of the pipeline with. However, part of our goal with sort of our long-term design is to have sort of as few disparate components within the pipeline as possible. And so since we're already using Trimmer to sort of move our raw data around, and we're actually moving to have it be at the front end of our pipeline, as well as on the post-Kafka side, writing to InfluxDB, we're looking in that direction just so that for our operational team, they're able to just focus on really getting a lot of knowledge on one tool as opposed to having a bunch of tools. But I think it's definitely something that you could architect with Flux. And I know, as you look towards sort of the Influx 2.0 model where sort of the read and write start getting a little bit more decoupled, it could definitely be something where using Flux to do the aggregate functions would work. I haven't spent enough time in Flux to know if it would be able to handle sort of the wide selection of measurements we have coming into our platform, just being able to sort of throw aggregate everything at Flux and have that be a simple Flux command. But it's definitely something that could be a possibility in the future.
All right. Guys, plenty of time. Like I said, if you do have a question for Chris, go ahead and submit it using the GoToWebinar control panel. Right now, that is all the questions that we have, but we'll go ahead and keep it open for just a few minutes and see if we do have any straggling questions come through. While we're waiting, I do want to remind the audience that today's event has been recorded or is being recorded. So if you miss any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email following today's webinar that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always find it there. You'll just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you. Like I said, the email that contains the link to access the webinar on demand should be coming out, I would say within probably about an hour or so after the event. So it should be pretty quickly. You should be able to access the webinar. Okay, guys, no other questions have come in. Like I said, though, I will keep it open here for just a few minutes. And okay, actually, I did just get something in. If you go back a few slides, why all the layers?
Yeah, no, it's a good question. So a lot of it is sort of just off of sort of the limitations that we found with particular layers. So once we realized we'd want to reuse our 10-second aggregate again to fuel the data going into the 1 minute and the 1 hour rollups, since we couldn't use the raw data there without just using huge amounts of RAM, we knew we'd need to move data from Kapacitor into Kafka or something else to consume it back out of layer. And so Kapacitor is only set up to directly write to an InfluxDB HTTP API. And so the only way we could get the data from Kapacitor to Kafka was to have a layer of Telegraf, which was just listening on that HTTP endpoint and then had a Kafka output plugin configured for it. And then once we have the data in Kafka, then we'd need a layer to get it back into it, which is why we end up with these layers here. So strictly speaking, we could have tried to have these capacitors writing directly to Influx, but the other problem we'd seen there is that capacitor is sending out all these series and points as individual write requests. And just with the number of measurements and points that we're creating, that's something that we really wanted to batch when we were writing it to the Influx storage cluster itself, in terms of making fewer API calls, just because something we'd noticed going back to our raw data pipeline was that the cluster was a lot more performant when we had larger batches and fewer overall calls to the API. So all this was really based on sort of tuning it so that we were keeping the overall hits to the right API as down as possible here, and then sort of some different technology constraints in terms of being able to have capacity to get the data into Kafka so that we could do the batching here and then use the 10-second rollup to feed our 1 minute and our 1 hour aggregates.
Excellent. Okay, great. I got a thank you from William who asked that question. So, okay, guys, last call for questions. If you have one, go ahead and put it on into the GoToWebinar control panel. And if we don't get anything in the next minute or so, then we'll go ahead and close it down, and we'll do our drawing for our $250 Amazon gift cards, and then we'll let everybody get on with their day. Excuse me. Guys, real quick, just also want to remind you, we have a ton of webinars on the devops.com website, so you can always check out what we've got in our inventory there. Lots of good content there, so that is always a great place if you're looking for new or very recent webinars, as well as webinars that we've done in the past. And as I said before, today's webinar is going to be joining the ranks of that on devops.com, of those webinars. So you can, while you're looking for this one today, perhaps you can also take a look at the ones that we have there in our repository. Okay, it looks like we are done with the questions. We haven't gotten any more in, so I do want to thank everybody who did submit questions. Real quick, before we close things out for the day, I do want to go ahead and do the drawing for the two $50 Amazon gift cards. Our first winner today is Irene O. Congratulations, Irene. And our second winner today is William M. Congratulations to you both. We'll be following up with you via email to get your gift card over to you, so please check your inbox. Also, let's see, want to thank Chris for a great presentation. Good stuff. It's always fascinating to see what's going on the back end of the larger companies, and looks like Wayfair's got some really cool things going on. So thanks for sharing, really do appreciate it.
Thanks for having me.
All right, all right. Also want to thank the audience for joining me today. I'm Charlene O'Hanlon, giving you 11 minutes back in your day, and I hope everybody stays safe. Take care.